Hello everyone, in this video I'm going to introduce how to use a StatCrunch to do the problem. But before you use the StatCrunch, I strongly recommend you read the book and also at least do at least one problem for each type of question and truly understand how to apply the formulas when we're going to use what kind of formulas to do the problem. And then you can use the software, for example Excel or StatCrunch, to do the problem. It's very important that at least you understand the meaning why we do this, and when we're going to do this. Okay, so look at the first problem. A random sample size n1 equals 25, sigma 1 equals 6, mean is 71, and n2 is 35, sigma 2 is 4, and x2 is 34. Is two sample standard deviation and the sigma, both sigma unknown. So we're trying to find the difference, sample difference. So we're trying to predict the mean value, the confidence interval for these two mean value. And there is two samples with the data summary. We don't have any data here. We just have summary of the data. So what do? We can type in two samples z. I'm going to do a brand new thing, then you don't have to get confused. New data table. Then stat z-score, two sample with summary. So mean value for the first one is 71, standard deviation 6, sample size 25, mean value for the second one 34, standard deviation 4, sample size 35, 96. Okay, so you can compare that lower limit 34.2, up limit 39.8. So that's it. Okay, next question. We have two catalysts, so basically two chemicals. Okay, we're going to use these two samples. Sample 1, 14. What do? They said they have equal variance. But what did they give to you? What the problem gives you is, sample 14 batches prepared, average and standard deviation. So basically, it does not give you the standard deviation of the population. It gives you two samples. So we have to use the t-distribution because the sigma is unknown for the population. So we have the sample variance is known. So two sample with a summary. Standard sample mean value. For the first one, sample mean is 75. Sample standard deviation 4. Sample size 14. Sample size second one 11. Sample standard deviation 5. 65. And because they have equal variance, so we're going to choose poor variance. Poor variance means they have exactly the same variance or from the same population. So we check the poor variance, okay? And then we choose confidence interval for 90%. So we got the lower limit 692, up limit 13.08. Okay, next one. You have two medication, N1 and N2. So actually, when you look at this, actually you find out U2 minus mu2 minus mu1. So when I do that, is still use sample t-distribution, two sample with data with summary. Instead of putting sample 1 here, because I'm looking for mu2 minus mu1, not mu1 minus mu2, right? So I put mu1, put all the medication 2 first. So sample mean is going to be 18. Standard deviation. Okay, so this one give you 1.3, which is not standard deviation is variance. So I need to put 1.14. The second one, sample mean, I need to put sample size is what? 11, 16. Standard deviation is 1.9. Take a square root is standard deviation 1.3, 1.378. and sample mean value 18. No, wait, 14. Okay, 16, 14, 1.3, 7, 8, 11, 1.14, 18, what percent? 90%. Okay, they're from the equal variance, so I check the poor variance, compute. You get 3.14 and 4.876. Okay. So this one, it would be very similar as the previous one. Okay, you have x1, s1 is given, x2, s2 is given. You would do exactly the same thing as the previous one. Okay, so there's not much difference from the previous one. You can do this one exactly like the previous one. Okay, you should be able to get exactly the same numbers. Alright, it should not be hard to do this one. It's the same thing as the previous one at 12, right? You just put 12 for both, and it should be fine for this one. This one, I want to introduce this one a little bit because you're going to conduct different statistics. For this one, we're going to do, we read the problem. It says what? Brand A and brand B observe. When you look at this A and B, to estimate difference in the two brand, I experiment to conduct in each brand. Assign at random to left and right real 8 axes. The tile run until they wear out a distance. A record and find the difference of mu1 minus. Assume the difference of the distance approximately normal distributed. So basically, first we don't have all of the data, so we have to copy this. We copy this to here, Control C, Control V to here. So what you need to do, everything is given. So sigma is unknown, x bar is unknown, so we have to do t distribution, but it's paired. We observe A and B. Look, you have UD, and anything else, you don't have the D. We are looking for the D, the difference of these two. So the observation of these two variance. So it's variance 2, variance 3. And if you want to see the difference, you can check it. If you don't, it's fine, and it's 90%. And compute it. You have the exact same number, 132 and negative 1,832. Alright, so next one. Okay, so this is the proportion test. Proportion one sample with a summary. So what you have to do here, it says 36 failed to test. So 864 passed it. So 900, confidence interval 95, and compute. You have that limit, lower limit, up limit. Okay, so this one is a sample size, proportion sample size. What you need to do is proportion one sample size. White sample size. What you need to do, confidence interval is 0.9, and the target proportion, it doesn't give you anything of the proportion, but what it only gives you is 0.06 of the true proportion. So positive 0.06, negative 0.06 together is 0.12. Is 0.12. So compute, the number is 188 for the sample size. Since it does not give you any of the targeted proportion, you just use a 1/2. Okay. 1/2 fail, 1/2 success, like that. All right. So next one. All right. So this is proportion. Okay. Proportion to sample with the data with the summary because we don't have anything else. So just type in 80 woman 225 and 30 being woman 175. Okay. And the confidence for P1 and P2 and the 99%. So you get, wait, let me check it again. Added. Alright, so 80 out of 225. 30 30 out of 175. And is there a significant difference between these two? So P1 minus P2, confidence interval for 99%. Let me say 228, 80, 225, 30, 175, and significant 99 confidence interval, and then you have standard deviation. Oh, it's right here. Yeah, 0.074, up limit 0.29. Since there is a reason to believe there is a significance, because P1 minus P2 not equal 0 at all. There's no zero. If they're equal, there's no difference. P1 should be equal to P2, but even the lower limit does not equal 0, which means P1 must be bigger than P2, because P1 minus P2 is positive, right? So they are not equal at all if you give 99% confidence interval. So it does not equal 0, then P1 not equal P2. So there is a significance between P1 and P2. Okay, so this one, you have sigma, we need to find out the variance. One sample with summary. Okay, so what do we need to sample variance? It give you it only gives you standard deviation of 25. So the variance you have to put 625. 25 square is the variance, and sample size is 13. And also confidence interval 95, and you do compute, and you have lower weight. Oh, take a square root again. So 321.38, take a square root, you get 17.93. And this is the variance. You take a square root to get the standard deviation. So 703, take a square root, you will get 41.27. Okay. The next one is the proportion variance. Variance status, 2 sample with data. Okay. So let me see. I don't have the data yet, so I have to copy that into here and copy this into the new stat table, new data table. Okay, copy that, paste it, and then I do stat variance stats 2 sample with data, and what I need to check is sigma 1 square over sigma 2 square, and is what, 90% confidence interval, right? And sigma 1 is very 1, sigma 2 is very 2, and then what you need to do, compute, and you get the lower limit, upper limit. What happened? These two never close to 1, so they are not equal at all for sure. Because sigma 1 square over sigma 2 square, the maximum value is 1/2. So we cannot assume sigma 1 square equals sigma 2 square. If they're equal, they divide with each other, it should be equal 1. But now the maximum value only give you 1/2, so they cannot be equal. So does not include 1, it should not be assumed they're equal. That's how you use a stack crunch to do the homework problems. It will be very quick if you use a stack crunch to do problem. However, I want everyone, you have to do at least one problem for each type of question in your textbook or from the homework by hand, and also view examples how to do it by hand, and at least understand that the meaning of each one of each type of questions. How are you going to use it in the future when you have a problem like this? Okay, so if you have any question, please feel free to email me. Okay, so that's it for the homework. Thanks.